In this video, we will do a few problems involving angle relationships. And let's start with the first angle relationships over here on the black screen. If you have a circle, here's the center. If you have a central angle, meaning an angle whose vertex is at the center of the circle, the angle is going to be the same measure as the intercepted arc. So let's say that this is an 80-degree angle. Well, this is the intercepted arc, and it is also 80 degrees. On the other hand, there's a such thing as an inscribed angle. So an inscribed angle is an angle whose vertex is on the circle itself. Okay, so this is an inscribed angle. The angle is going to be half the measure of the intercepted arc. So let's say that the intercepted arc, let's say it's still 80 degrees. The inscribed angle will be 40 degrees because it's half. So memorize these two situations. We're going to need that for the first problem. Okay, so I see this angle right here, the 80. The intercepted arc is this arc right here. Alright, that's right inside that angle. So the angle is half the arc measure, or you could say the arc measure is double the angle. So if this is 80, then this arc is going to be 160. Okay, now we're supposed to find the measure of angle COA. Well, angle COA is this angle right here. Okay, angle COA is a central angle. So the angle and the arc should be equivalent. So that means this central angle should be 160 degrees, just like the arc that we just found. So the answer should be 160. Kabam! Before we even do this problem, let's solve for what we can. Okay, they gave us all these markings and 60 degrees. Focus your eyes on this quadrilateral right here. The angles inside of a quadrilateral add up to 360 degrees. So I should be able to find this angle right here by starting with 360 degrees and subtracting the 60 degrees, and by subtracting the two 90s. Whoops. Alright, if I subtract all three of these angles away from 360, that should leave the other one. So 360 minus 60 minus 90 minus 90, that's 120 degrees. Okay, so angle C, well, angle ECD is 120 degrees. This is a central angle, so that means that the arc, the intercepted arc, should be the same measure. So this arc is also 120 degrees. Now this angle right here is an inscribed angle. Okay, so I'm talking about this angle right here. So I've got the intercepted arc and I've got this inscribed angle. And like I just reminded you, an inscribed angle is going to be half the measure of the intercepted arc. So if this is 120, then this should be 60. Okay, can I find anything else? Well, just for good measure, I could tell you what this whole arc is right here, because I've got 120 right here. So if I start with 360, because that's the whole circle, and I subtract 120, that's going to leave 240. Okay, so 240 is the entire purple part here. Or if you think of it another way, if we take the 240 and split it, see how these marks are equal? The chords are equal. That means that these two arcs are equal. So this arc over here, alright, half of 240 is 120. Alright, I just divided by 2. So that means this is 120 and this is 120. Alright, if the chords are equal, then the arcs are equal. Okay, so now that I have all that good information, I should be able to zoom out and answer the questions. Okay, which statements are true? Check all that apply. Angle EFD is congruent to angle EGD. Okay, EFD is 60. EGD is also 60. So that's true. Alright, EGD is congruent to ECD. EGD is 60. What about ECD? ECD is 120. So those are not congruent. Arc ED is congruent to arc FD. Okay, arc ED is 120. Arc FD is also 120. So those are congruent. The measure of arc EF is 60 degrees. No, the measure of arc EF is 120 degrees. So that's false. The measure of arc FD is 120. So there's arc FD, and yes, it was 120. So that's true. So these should be the answers. Oh yeah. Okay. Okay, again, let's figure out whatever we can before we even look at the actual questions. So the only number that they really give us is I have 90 degrees in this angle right here. This is a central angle, so that means that this intercepted arc, alright, so I've got this angle, okay, and it has this intercepted arc. So because this is a central angle, that means that this intercepted arc is 90 degrees. Okay, so this entire blue arc is 90 degrees. Now, because of the symmetry, this is split right down the middle. See the markings on the left and right? That tells you that these sides are congruent. Alright, that means that the entire left side of the circle is congruent to the right side of the circle because I've got this diameter going down the middle. So that tells me that this is going to be 45 degrees and this is going to be 45 degrees. Okay, good to know. Now, the entire circle is 360 degrees. So if I start with 360 degrees and I subtract 90, okay, what's that going to give me? Alright, so that's 270 degrees. Okay, so that's 270. So, the rest of the circle is 270. But let's go ahead and divide it into two equal parts. So if I take that 270 and divide by 2, that's going to be 135. So that tells me that this portion is 135 degrees and this portion is 135 degrees. Alright, if I add up these three numbers, that's going to make 360. Okay, anything else I can just say off the bat? Just in case it comes up, this is the central angle right here. So the central angle and the arc have to be the same. So this is 135 degrees. Similarly, this is 135 degrees. Okay, I guess I will stop there and start answering questions. Now, if they needed me to find these smaller angles, I could. But I better just wait and see what they actually want me to find. What is the measure of angle ACD? Okay, what are they talking about? Angle ACD. Whoa, I cannot draw today. Let me try that again. Okay, we need to find the measure of this angle. Okay, to do this, we're going to have to use our knowledge of isosceles triangles. Okay, look at this triangle right here. Okay, this is an isosceles triangle. So I've got this. Oh, by the way, the way I know it's an isosceles triangle is because this is the center of the circle, and this is a radius of the circle. Okay, and this is another radius of the same circle. All right, so any radius of this circle will be equal. So these are definitely equal. So that's how I know that this is an equilateral triangle. Now, the reason why it's important is because the base angles of an equilateral triangle are equal. The base angles are equal. So if I know that this is 90 degrees, okay, as you can see, this is 90 degrees, I should be able to find what the other angles are. The total sum of the angles in a triangle is 180. So if I do 180 minus 90, that's 90. Okay, so that leaves 90 degrees to be shared equally between these two base angles. So that's going to be 45 and 45. So this is a 45, 45, 90 triangle. So this is 45 degrees right here. Okay, now, let's see if I can just make this yellow part go away. Now focus your eyes on this triangle right here. Alright, that is an isosceles triangle as well. Okay, in fact, I'm just going to redraw it to make it more obvious. Alright, so we have this isosceles triangle kind of doing like this. And so we have 135 degrees right here. Now, this side is congruent to this side. Alright, that's what I mean by isosceles. And again, the reason why I know that is because this is a radius of the circle, and this is also a radius of the circle. Okay, radii are always equal to each other. So again, I should be able to start from 180 and subtract the 135. Okay, so that is going to be 45 degrees. So this 45 degrees actually has to be shared evenly between these two angles. So that turns out to be 22.5. So each of these angles are 22.5 degrees, which means that this angle right here, okay, is 22.5 degrees. So don't forget what we are supposed to be finding. Alright, they asked us to find the measure of this angle right here. Alright, we're finding this pink angle. Well, the angle is going to be the sum of these two pieces. Alright, it's going to be the 22.5 plus 45. Put those together and that should be our answer. So the answer should be 67.5 degrees. Okay, so I'm expecting this to be the answer right here. Oh yeah. Alright, well, the measure of minor arc JL is 60 degrees. So this arc right here is 60 degrees. They want us to find the measure of angle JKL. Okay, angle JKL is this angle right here. Alright, I'm going to call it theta. That's what we're trying to find. Alright, well, let's see what we can do. This is a central angle. So, this is a central angle. So it should be the same as the arc. So if this is 60, then this is also 60 degrees. Okay. Now, these two lines, okay, that I'm about to draw in blue, this is a tangent to the circle, as you can see. Like if I kept going, it would just skim across. So that is a tangent. And this is also a tangent to the circle. Okay? So, if those are tangents, then that means that these are 90 degrees. All right? Tangents to the circle are always perpendicular to the radius. So I've got 60 and I've got 90 and I've got 90. So now all I need is to subtract from 360. All right, this quadrilateral right here, all right, this kite, a quadrilateral has a total angle measure of 360 degrees. So if I subtract the two 90s and the 60, that should give me the measure of the other angle, and that's what we're looking for. So this should give us the answer. Alright, so the answer should be 120 degrees. And there you go. Alright, take a close look at this picture. They are asking us to find the measure of angle EFD. Okay, angle EFD is this angle right here. Okay, notice that this is an inscribed angle. This situation where the angle is half of the intercepted arc, and this is the intercepted arc. So the angle should be half of this, so that should be 34. So that's it. The answer should be 34 degrees. Nice.